For the next question, we're looking at this inequality. So let's do it. So we have that we need to solve this inequality. So for such an expression, we can take it as it is and we equate it to 0. Then we solve for x. So we can use the product sum or the quadratic, but let's use the product sum method. So if you look at this expression, our product is 2 and our sum is -3. So if we look for two numbers that if we multiply them, they give us +2, and when we add them, they give us -3. That is -1 and -2. So we'll replace them on our sum. So that is x squared minus x minus 2x. So we replaced the two numbers, which is -1 and -2, but we maintain everything as it was. So +2, we can now say equal to 0. Then we group the terms. So if we group at this point, we also group at this point. So we have x being common, then x minus 1. On the other side, if we factor out -2, we have x minus 1 equal to 0. Then we factorize again, so we have x minus 1 and x minus 2 equal to 0. And if we use the zero product rule, we'll have x minus 1 is equal to 0, and also having x minus 2 equal to 0. So our critical values for this expression are x is equal to 1 and x equal to +2. So now we need to use our number line to get the interval where this inequality lies. So with our number line, we can draw that. Then we have from -infinity, we have a +1, we have a +2, and we have +infinity. So these are the variables we work with. So from 1 all the way to infinity, we can pick any number that we can use to place at this point to determine if the number suffices or not. So remember, the expression we're dealing with says greater than 0. So whatever solution that we get, we'll try to compare with that. But for now, let's just solve. So from 1 all the way to -infinity, we can pick any number, but it's best we pick a small number. So the number we can pick is 0. So we pick x is equal to 0. So at this stage, we replace 0 wherever there is x. So that means we'll have 0 minus 1 and 0 minus 2. This will give us -1 by -2, giving us +2. So we're getting a positive number. Then we come to this interval here, 1 all the way to 2. The number we can pick is half would be okay. We'll pick half. Sorry, not half, 3/2. Half is this side. So we pick 3/2. 3/2 is the number in between 1 and 2 that we can pick. So we replace 3/2 at this stage. We'll have 3/2 minus 1, and we also have 3/2 minus 2. Okay, 3/2 minus 1 we get half, and 3 over 2 minus 2, we get negative half. So when you multiply the 2, we get a negative number, because half multiplied by negative half will get a negative number. So at this interval, we have a negative. Then the final interval we have is from 2 all the way to infinity. So we can pick 3. So replacing in our inequality, we'll have 3 minus 1 and 3 minus 2. So this gives us 2, positive 2, and 1, giving us a positive number. So there will be a positive number there. So now, if you go back to the original inequality, the expression said greater than 0. So we're dealing with expressions that are greater than 0, which is, those are positives. So this part gave us positive, and this part gave us positive. So those are the intervals we're dealing with. So presenting our answer in interval notation, our final solution is that we're moving from negative infinity all the way to 1, but open. Then this is union 2 from this part, again going to infinity to infinity. And that's our final solution.